Hi guys. So now we begin with our 11th chapter, which is introduction to, or name of the chapter is loan schedules. I'll be looking at the introduction today to the chapter. Okay. So before I go ahead, I'll just quickly recap what did we do in equation of value. So when we were doing the equation of value, I told you that this equation, which is present value of cash inflow is equal to present value of cash outflow, is used to evaluate certain things. Okay, it's used to evaluate certain things. Those are financial instruments or securities, investment proposals, or loan. Now, guys, each of these three applications of equation of value are our further chapters. So chapter 11 is what we discussed, the application of equation of value in loans. Chapter 12 is we discussed it for investment purposes. Let's say given a project, how do I evaluate whether it's profitable, is it good for investment or not? And chapter 13 we evaluate securities, okay, like bonds, debentures, and equities. Okay, so today our focus will be on loan. So we are going to learn how do you understand loans, how does the mechanism of a loan work, and how do you find various stuff to be calculated in the loan. Okay, so let's begin. So when I talk about a loan, okay, so there are broadly, guys, four elements to a loan. Okay, element number one is obviously the rate of interest. Element number two is the loan amount. Element number three is the term of the loan. And element number four is the installment. Now, each of this is given by a notation for us. So the rate of interest still remains I, which is effective. So I is which is per annum effective. Loan amount for us is given by L0. Term of the loan for us is given by N, and installment is given by X, or I'll put that XT, where XT denotes the tth installment. So if I say 1 X1, that basically means the first installment. Yeah. So basically 1 here refers to the first installment. If I write X2, I'm referring to the second installment, and so on. Yeah. So generally the subscript will not be of importance if the installment is the same, but I'll want to continue with the notation throughout. Okay. So these are the basic elements to any loan, and we will be required to find these basic elements. Okay. So when I talk about this chapter, so we will be having two parts to this chapter. The first part is basically finding elements of a loan. Yeah, those elements, okay, are what we already discussed: the loan amount, the term of the loan, the installment amounts, or finally the rate of interest. Now, irrespective of what is asked in the elements of the loan, all of these will be solved by the equation of value. So basically, I just have to make present value of cash inflow is equal to present value of cash outflow and find any of this. कोई भी एक चीज ढूंढना होगा, I'll immediately find it. I'll make my equation of value and I'll find either the loan amount or the term or the installment or the rate of interest depending upon whatever is asked in the question. So, but it will be simple equation of value. If now rate of interest was asked, if you guys remember, whenever rate of interest is asked, we use trial and error. So we will have to use here a table function. If the term is asked, we already discussed that we use logs. Considering that the power function has to be found, we'll be using natural logs. Whatever we did equation of value basically comes here again. So inflow outflow X, which may be either the loan amount or the installment. I, we already discussed table function, and if it's the term of the loan, we typically find n, which is log natural, or the logs of both sides. So this is one part that we already discussed in equation of value, will come again in a loan. Now apart from that, we would be required to find certain things, certain values during the period of the loan. We have to find certain values during the period of a loan. Okay, so now this may be the first thing. This may be the principal amount or the interest amount for a single installment, or they may be the principal amount or the capital amount also called, or the interest amount of multiple installments. Finally, it may be also find the total interest paid during the loan. Yeah. Now typically when I look at a question, it will be on both the parts. So matlab initially they will say that find the loan amount, term, installment or rate of interest, and after that they will say that during the term of the loan find the principal component and the interest amount or the of a single about, will be involving both of them. Okay. Now just to reiterate this part, so when I take a loan, guys, whenever I take a loan, okay, so let's take the example that we did in the equation of value only, so that we have the same thing in our mind. So let's say there was X, an actuary. Yeah, let's say there was X who was an actuary who had taken a loan to buy a car. Okay, he had taken a loan of 40 lakhs for a period of 10 years. Okay, and we calculated the installment amount to be 6,50,981. Okay, so we had X who had taken a loan of 40 lakhs at a rate of interest of 10%, and the installment amount X was 6,50,981. Now guys, this 6,50,981 includes both. It includes interest and it includes principal. Okay, so this 6,50,000 will include both interest and principal, but the proportion of interest and principal keep on varying. So the proportion of interest and principal keep on changing. So if I talk about the loan, so let's say my x-axis here denotes my term, my y-axis denotes amount. So let's say this 6,50,981 will remain constant, which is my EMI, which will always be constant. I don't change. So for all the 10 years, my amount of installment will remain 6,50,981. Now, but within that 6,50,981, some things keep on changing, right? So what are the things that keep on changing is the interest and the principal. So if I have to plot interest, initially the interest is high and subsequently it reduces. Okay, so here the black part or the black line denotes the interest component. It is the interest component of an EMI. This 6,50,000 can be bifurcated into interest and principal. If I look at the first installment, interest is high. If I look at the second installment, it reduces. Third, it reduces, and so on. It keeps on reducing. the principal follows a reverse trend. Initially it is very low and subsequently it keeps on increasing. So the green one that I've highlighted here is the principal component of my installment, which basically increases with the number of installments. Okay, our work throughout this chapter is trying to find either the principal component or the interest component of a single. So let's say if this is a 10-year loan, I want to find out 8th installment ka interest principal kya hai, ya fir 7th installment ka what is the interest, what is the principal. I can do that. Or I may be also required, let's say in the first 5 installment, what was the total interest, total principal. Yeah, in the last 5 installment, what was the total interest or the total principal. And finally, what was the total interest that got repaid during the loan. Okay. So these are very, very fundamental questions, guys, which everyone needs to understand. So anyone who takes any loan needs to understand how much of interest is there, how much of principal is there, how is he going to repay the loan, bank is earning how much, he's paying how much. So this is a very, very practical thing that we are looking at, guys. Okay. So now let's go ahead. Now, considering that, guys, we already did all of this, which is loan amount, term, installment, rate of interest, when I look at my equation of value example. Okay. So in case you want to recap any of this, you can go through that video. Okay. But it is absolutely the same. I will be focusing for this chapter on the second part, which is the blue part here. Okay. So before we go ahead and start finding that, we need to understand the loan amount outstanding at different points in the loan. So before we go ahead and find the principal and interest component, we need to find or understand this first. So I go back to the original example that we had. So let's say at time 0, 40 lakhs was borrowed, against which an installment of 6,50,981 is being paid every year for a period of 10 years. Okay. Alright. Now, before I get into the example, there is one notation that I want everyone to be very, very clear with. Okay. Very important to understand this notation clearly, which is LT, which basically says the loan amount outstanding after the 10th installment. Yeah, guys, the important thing that we need to understand here, it is after the 10th installment. Okay. So when I write L0, it basically means loan amount outstanding after the 0th installment or before any installment. Yeah. Loan outstanding at the beginning because there has been no installment done, which can also be said at time 0. When I write L4, it is loan amount. Yeah, when I write L4, it is loan amount after the 4th installment. Yeah, it is the loan amount after the 4th installment. Now, guys, what I need for you to focus on is here, I am not defining it in time. I am defining it in time of in terms of installment. So if I take the example that's put up here, so L4 will be when 4 installments of 6,50,981 are done. So if I put here 4, it will be 1 ka installment, 2 ka installment, 3 ka installment of 6,50,981 and 4th installment of 6,50,981. After all these 4 installments are done, I am looking at L4. Okay, what will be the loan amount outstanding? Now, will my answer be different if it was advance? So let's say if this was advance. Okay, so which basically means, let's for the sake of example assume that the amount remains constant or same. So at time 0, it will be 6,50,981. At 6,50,981 at time 1, 6,50,981 at 2, and finally 6,50,981 at 3. So these 4 installments are done. Will I include the 5th installment which will come at time 4? No. So even if I'm looking at advance, this installment which is coming at time 4 will not be included because I'm writing L4. L4 is the value of the loan after the 4th installment. If it is in advance, it takes into account installment number 0, 1, 2 and 3. Okay. So I want everyone to be very clear with this notation, which is basically it is after the 10th installment. Even if it is given in time, guys, you will be very comfortable to digest it and do it properly. We will always take it in the form of installments. Cool. Okay. So now let's say I take this ahead. I'll draw the timeline again. Yeah. So at time 0, we have 40 lakhs. At time 1, there is an installment of 6,50,981. This goes on till time 10. I want to find, let's say, 4, L4. Yeah, I want to find L4, which is basically the loan amount outstanding after the 4th installment. Yeah, after the 4 installments are done, what is the new loan amount outstanding? Okay. All right. Now to find this, there are 2 ways, guys. The first way is called as the prospective method. The second way is called as the retrospective method. Now let's try to understand both. Okay, prospective. Now, as the name suggests, prospective is basically looking forward. So for us, if we are looking forward, we are looking at future cash flows. If I'm at time 4, I will look at all cash flows after time 4. Okay. And the value of the loan will be basically the present value of all future cash flows. So if I'm talking here from time 4 till time 10, okay, so till 4 installments are done, can I say after 4 6 more installments are left? Okay, so L4 will be equal to the present value of all 6 installments. 6 installments, which will be nothing but 6,50,981 A6, because there are 6 installments left. Yeah, so this will become the value of the loan, or yeah, so if I put it up, I'll just open my calculator. Yeah, so for me 6,50,981 A, so 1 minus 1 plus I, so that's 1.1 x raised to minus 6, which are the installments left. Take it down. The whole divided by I. Okay, so again 0.1. Yeah, so that becomes 28 lakhs 35,191. So that becomes 28,35,191. Cool. Now when I talk about the retrospective method, I hope everyone's clear. Yeah. Now I go ahead retrospective. It's actually the opposite. So it basically means looking backwards. Or in other words, we are talking about past cash flows. So here we basically take the accumulated value of all, instead of future, past cash flows. So L4 will be accumulated value of all past cash flows. Now the point here guys is that past mein there were two cash flows. If I look at time 4 ke pehle, there were two types of cash flows. One was the loan amount and one was the installment. Loan amount was inflow, installment was outflow. Okay, so I'll have inflow outflow, so I'll have to use negative positive. So since 40 lakhs was inflow, using I don't know what, since 40 lakhs was inflow, using a positive, I'll have to accumulate that, so we'll accumulate it till time 4, minus my accumulated value of 6,50,981 into S4. Okay, so now I have taken the accumulated value here. Obviously answer under both of them need to be the same, so I can do the answer under both of them. Okay, so 40 lakhs into 1.1 raised to 4 minus 6,50,981 into 1 minus 1.1, yeah, again x raised to minus 4, oh my bad, 1 plus I raised to n minus 1 upon I is the formula for s, so doing that 1.1 the whole raised to 4, yeah, minus 1 divided by 0.1, yeah, 28,35,000. Yeah, again I got the same thing, which is 28,35,000. Yeah, you will say, sir, thoda sa difference hai. It's purely because of rounding. I'm not taken the full installment value here, 981 point something something tha. So there will be some element of rounding. Yeah. So answer under both the methods is same. So then the question comes is when to use which. So guys, by default, we will always use prospective method. By default, we will always use prospective. Retrospective is to be used only when obviously one specifically asked. It's very rarely specifically asked, so it will never be the case where you're specifically asked do by retrospective only, but still. And second is a very special condition where there are varying rates in the question. Varying rates, and you have been told to find the loan amount outstanding towards the start. I'll give you an example. So let's say यही example ले लेते. Let's say here I have been told that 0 to 5 it is 6%, and 10%, and 5 to 10 it is 11%. So you have a different rates, right? Now, so if I have different rates, so let's take this example. Yeah, time 0 you have 40 lakhs, 0 to 5, the rate is uh, 10%. 5 to 10, the rate is 11. Yeah. Now let's say the installment amount is 6,50,981. Guys, it will not be. I'm just, for the sake of example, I'm putting it here. Yeah. Let's say 6,50,981. I have been told to find L4. So if I follow the prospective method, L4 will be equal to, we will look at the future. So we will not look at 4K pehle, 4K baad. There is one installment of 6,50,000 coming at time 5 and 6, and then 6 installments of 6,50,981. Now the problem here is there are different rates. Since there is only one installment coming at time 5 of 6,50,981, I can say 6,50,981 A1 or directly put it V, plus the remaining 5 installments from 5 to 10, 6,50,981. The remaining 5 installments, so A5. Yeah. Now the point is, I'll get the value at time 5. I will have to take it to 4, so another V. Now the problem here is, guys, this will be done at 11%. This will be done at 10%, and this will also be done at 10%. Why? Because all cash flows before time 5, which is this, will be at 10%, and all discounting before time 5 also is at 10%. So you may go wrong. Okay, there is a high probability of making a mistake. But when I talk about retros in this case, so 40 lakh will get accumulated till time 4 at 10% minus 6,50,981 S4. Here there is only one rate, so you will not go wrong. From 0 to 5, the rate remains the same. Cool, guys. So only when these two conditions are there, we will use retros. Otherwise, throughout this, we will be only looking at prospective method. I hope I'm clear, guys. All right. So now we go ahead to finding the interest and the capital component or the principal component of a single installment. Okay. Yeah. So when we started off, we basically said that we can be asked interest or capital components of a single installment or multiple installments. So first we will do for a single installment. Okay, I continue with my same example, guys. Yeah, so the example remains the same. There is no change whatsoever. So at time 0, 40 lakhs is borrowed. Each year we are being paid 6,50,000, or there is an installment of 6,50,000 till a period of 10 years. Now, let's say I have been told to find the interest and the capital component, of, let's say, the 5th installment. Yeah. When we started off, we just discussed that though the EMI remains the same, though this 6,50,981 remains the same, the proportion of interest and principal keeps on changing. Typically, the proportion of interest goes on decreasing, the proportion of principal goes on increasing. So now I have to find it directly for the 5th. How will I do this? So what I'll do, guys, is I'll not directly get onto the formula. I will try to drive it more intuitively. Okay. So let's say इसके जगह पे मेरे को बोला होता find the interest and capital component not of the 5th. Let's say the first installment. Okay. Now the first installment is 6,50,981. Yeah. Can I say first time I had borrowed 40 lakhs? So can I say the interest will be equal to 40 lakhs into whatever is the rate, in our example 10%. So can I say the interest will be 4 lakhs? Yeah. The principal or the capital component will be nothing but the balancing figure. So it will be whatever x minus the interest component. So x for us is 6,50,981 minus the interest of 4 lakhs. So the capital component is 2,50,981. So in the first installment, I paid 4 lakhs as interest and 2,50,000 was paid to repay the loan of 40 lakhs. 4 lakhs was interest, 2,50,000 was paid as principal to repay the loan. Okay. Now, ये the first installment का था. My original question was the interest and the capital component of the fifth installment. So जब first चाहिए था, I went to L0. This is L0, right? जब first चाहिए था, I went to L0. So can I say जब fifth चाहिए था, I will go to 4. So the interest component will be L4 into I. The rate of interest remains the same. L4 we will calculate using the prospective method, yeah, which is I am at time 4 and I'm looking at the future from 4 till 10. Okay, so from 4 till 10 there will be installment of 6,50,981 A6 into whatever is the rate of interest 10. We will calculate this. We just calculated this as an example. Yeah, we got this 28,35,191. So 28,35,191 into 10%. Yeah, so this becomes 2,83,519. My capital component is the balancing figure. Again, x, which is 6,50,981 minus the interest component 2,83,519. Yeah, I'll do that. 6,50,981 minus 283,519. 367,462. Yeah. So if you see my narrative also that I was referring to, first installment had 4 lakhs interest. The fifth installment has only 2,83,000 interest. First installment had 2,50,000 as principal. Fifth has 3,67,000 as principal. Okay. So I can do this for any of the installments. I can do it for the third, seventh, sixth, fourth, second, any installment. Okay. So I can generalize this now. I'll try to make a formula out of it. So if I have been told for interest and principal component of the nth installment, or let's say 10th installment. Yeah. So I will first find LT minus 1. Yeah. So first find this. So step 1 will be find LT minus 1. So in this example it was fifth, so I calculated L4. Then the interest component will be nothing but LT minus 1 into I. Now guys, I'm making this generalized. It will be IP by P if Pthly. In my example, since P was 1 annual tha, to सीधा I हो गया. But it will be IP by P for Pthly installments. Huh? And the capital component will be nothing but my X, whatever is that X, T, writing it, whatever the Tth installment is, minus the interest component. Yeah. Cool. So I'll use this now as a formula through and through to solve any sums, but this is only for one installment, guys. I'm not talking about multiple. I'm talking about a single installment. Cool. Let's look at a sum, and I'll look at a pthly sum so that we get a good practice of it. Cool, guys. This is your fifth sum of your assignment. A loan of 35,000 is to be repaid over 10 years by a series of level monthly installments payable in arrears. Interest rate is 5% per annum. Calculate the monthly repayment, the interest component of the 37th, the capital component of the 85th. These two we haven't done. These are multiple installments which we haven't done till now. So I'll just focus on ABC. So let's look at A. A loan of 35,000. So I'll draw my timeline. So at time 0 it is 35. It is to be paid by a series of 10 level monthly installment. Now guys, whatever I assume X as is very important. So I'll say let the monthly installment be X. Yeah. So 1 by 12 पे X आएगा, 2 by 12 पे X आएगा, and this will go on till time 10 years. Yeah, जब भी वापस X आएगा. The rate of interest being charged here is 5%. Calculate the monthly repayment. So monthly repayment is nothing but my installment. Okay, so we will use our equation of value. So by equation of value, present value of cash inflow is equal to the present value of cash outflow. Present value of cash inflow is equal to present value of cash outflow. So inflow for us is the loan amount, so 35,000. Outflow for us is this X, which is paid monthly for 10 years. Okay, since it is monthly, I will make it 12x. 12x will become annum. A10 payable monthly. If you are working in monthly scenarios, this will be XA120 at the rate IP by P. Yeah, whatever you are comfortable with. Yeah, so now I will find my value here. Okay, I have to find X. So I'll say X is equal to, yeah, I go back to my calculator. Now I require, we know the formula here, I will require L12, I12. So first I'll calculate I12. So it's 1.05, the whole raised to 1 by 12. Minus 1, the whole into 12. Yeah, so I will just store this. So shift, store, let's store it in A. Yeah, so now I've got my I12. Now I apply my formula. So that will be 12 into, yeah, so 12 into A 10 12. Yeah, so that is nothing but, I'll make my 1 minus 1 plus I, so 1.05 raised to minus 10, the whole divided by I12, which I already have stored as A. Yeah, I get my answer here, 94. Yeah, 35,000 divided by the answer. Yeah, so X is here 369.33. 0.33233, yeah, which is the answer. So I've now got the monthly installment. The monthly installment is this. Now the interest component of the 37th repayment. Yeah, so the interest component of 37th. So guys, again the same thing. 37th, I have to do LT minus 1. So 36, I have to find L36. 36 is basically 3 years. Yeah, I am at time 36 by 12, which is 3 years. I am looking at the future. So after 3 years, more 7 years are left. The installment remains the same. So 12 into 369.33 for a period of 7 years, payable monthly. If you are doing the monthly fashion, it will be 369.33. A 7 into 12, 84 installments are left at the rate IP by P. Yeah. I'll simply get this value. I get L36. So yeah, so this 369. So I can directly put my answer into 12 into, open my bracket, get my fraction through 1 minus 1.05, which is 1 plus I, the whole raised to minus 7. Yeah, then come down again. I'll require a denominator may I12, so storing, recalling my variable alpha, closing this. This gives me the loan amount outstanding at time 36, which is 26,227.66. Yeah, so for me the interest component will be whatever is L36 now into IP by P. Yeah, why I'll have to do that? Because this is monthly effective. So whatever is my answer, yeah, answer basically here into IP by P. IP I've already stored as A. Divide that by, yeah, I already have stored it as A. I'll just use the fraction. Yeah, alpha A. Yeah, divide that by P for us is 12. So this becomes my interest, which is 106.85. And that becomes my interest component. Now I have to find the capital component of the 85th. Guys, I'm doing this for the first time, but I think ideally I would request you to pause the video, try the second one on your own. Yeah, the capital component of 85th repayment. Again, one installment before L84. Yeah, T minus 1 will calculate L84. 84 here represents basically 84 divided by 12 will be 7. So I'm only left with 3 years now. If I'm looking at the prospective method, so using it for 3 years, so 12 into 369.33, A, 3 years are left, payable monthly. Get my answer here. Yeah. So 12 into 369.33, 12 into 369.33 into, this is my fraction, 1 minus 1.05 raised to minus 3 raised to minus 3 upon, again, I12. So I'll use alpha A. I've stored that value. Yeah, so this becomes my capital component. Sorry, this becomes my value of the loan at time 84, 12,343.4847. I'll calculate the interest. Yeah, which will be this into IP by P. So again, alpha. Yeah, I'll use my fraction alpha A divided by 12. This is my interest component, which is 50.288. Yeah, therefore my capital component will be my installment amount minus the interest. So 369.33 minus 50.288. 2889, which is 319.04. Yeah. I hope I'm clear, guys. We'll not do the fourth and the fifth one because we haven't touched that piece yet, which is multiple installments. Okay, I'll do one more sum, guys. Now this is purely from the nature. Up till now, we have assumed that our X has always remained the same. The installment amount has not changed. But practically it can change, right? Installment may be an increasing annuity, maybe a decreasing annuity. So let's do a sum where my installments are varying annuities. Okay, this is a very good sum. It is April 2013, question 10. A loan is repayable by annual installment in arrears of 20 years. The initial installment is 5,000 and each subsequent installment decreases by 200. The effective rate of interest is 4%. Now calculate first the term of the loan and the capital component of the 12th installment. Yeah, so first I'll draw my timeline. So at time 0, there is some amount borrowed. I don't know that amount, so I'm putting that at L0. The first installment is 5,000, and after that every installment decreases by 200. So the second installment will become 4,800. The third installment will become 4,600, going on for a period of 20 years. Okay. The last installment, guys, we will use the formula here. I see 200 decreasing every time, so I'll use the formula of the AP, which basically says the nth term is A plus n minus 1D. Here A is 5,000, n is basically 20, so 19. D here it's a decrease of 200, so minus 200. Yeah, this will become 3,800, 19 into 2, so I'm only left with 3,800. Oh, sorry, my bad. I'm left with 1,200. Now I have to calculate the original amount of the loan. So I have to make my equation of value, which is present value of cash inflow must be equal to the present value of cash outflow. Inflow here is the loan amount itself, so L0. Cash outflow here. What sort of an annuity is this, guys? Yeah. What sort of an annuity it's decreasing by 200 constant. So it's decreasing by a constant amount. It is decreasing by a constant amount. Yeah. So the first payment is P. The second payment is 200 lesser. So can I say Q is minus 200? I'll use my formula P minus Q AN plus. So I'll use my formula P minus Q AN plus Q IAN. P is 5,000 minus of minus 200 becomes 5,200. A 20, so 20 years, plus Q here is again negative 200, so it will become minus 200 IA 20. Yeah, I'll get the loan amount. The loan amount is 45,638.56. Yeah. I hope everyone will now be able to do the math. Now I'll not use the calculator so frequently. I hope everyone can do the math. Cool. Now we go ahead to the second part, which is calculate the capital repayment of the 12th installment. So the second thing, capital repayment of 12th. Now since it is arrears, this 12th installment will come at time 12. Now ideally इसके पहले वाले सब में 12th बोला होता तो मैं डायरेक्टली निकाल लेता because the installment was constant of 369 odd. यहाँ पे the 12th installment will not be 5,000. It will be different, right? So first I have to find the 12th installment. Again I use the formula for that AP, A plus n minus 1D. A for us is 5,000. 11 into negative 200. Yeah, because D is decreasing by 2, so 2200. So this will become 2800. The 11th installment is 2600, and so on. The last 20th installment is 1200. I have to find the capital component in this 12th, which is 2800. Okay, so if I have to find the installment of the 12th, I'll have to find L11 first. Again, we use the prospective method. 11 से मैं आगे देख रहा हूँ, so there are 9 more installments left. But now my PQ will change. Okay, this will become my P because this will be my first installment after time 11. Q is reducing by 200 only. So again, I apply the same formula, P minus Q. So that will become, sorry, my bad. The 11th installment will be, 200 rupees higher. 3000, guys. Sorry. Yeah. Coming back. Yeah, so P is 2800, Q is negative 200. I again apply the same formula. So 3000, 9 years are left. So 3000 A9 minus 200 IA9. Yeah, I'll do my calculations again. Okay, and I'll find the value. The value for it is 15,258.67. Yeah, now I'll find the interest. Therefore, the interest component will be 15,258.67 into IP by P. In this case, it's 1, so simply into I. I for us is 4%. Yeah, so which is 610.346. And the capital component will be the balancing figure of the 12th installment. So it will be 2800 minus 610.346. Yeah, which will be equal to 2189.65. Yeah. So guys, when it is varying, please be careful of how the varying happens. Accordingly, you'll have to modify your calculations. Okay, because you'll need to find that installment at that particular point of time. When it's fixed, it's simple. When it's varying, it's also simple. It's just that you have to be careful. Now look at this. Now after the 12th installment is paid, so after this is paid, the borrower and lender agree to restructure the debt. The 200 reduction per year will no longer continue. Instead, future installments will remain level at the level of 12th installment, and the remaining term of the debt will be shortened. The final repayment will then be reduced amount, which will clear the debt. Calculate the remaining term and the reduced amount. Cool. I hope everyone got the question. What does it say? That after the 12th repayment, so after time 12, so that becomes this for us, 0 for us. Now the further reduction of 200 won't happen. The installments 13 onwards will remain 200 only. Now ideally, since the installments are not reducing, I am paying more. So can I say that since I am paying more, the loan will get repaid at a faster period? I will not have to wait for the 20 years. It will get repaid at a faster period. Yeah. So this becomes time 0 for us. This will be time 1 and whatever that time n is. Yeah. Now the first thing is I have to find this loan amount outstanding at time 12. I already have at 11. I have the capital component here. I can simply say L12 will be nothing but L11 minus the capital component of the 12th installment. Yeah. So it will be 15,258.67 minus 2189.65. Yeah. 15,258.67 minus 2189.65. 13,069. Now this is to be repaid over the remaining period. So I'll make my equation of value. So present value of cash inflow must be equal to present value of cash outflow. The amount of loan here is 13,069.02 is equal to outflow 2,800 A N. Yeah, now it will remain constant, guys. So no need of PQ. It remains constant at 2,800 for the remaining period. So I'll find N. So what will happen? Yeah, 13,069. This will be divided by 2,800. So this will become 4.6675 is equal to, I'll open out this bracket, 1 minus 1.04 raised to minus n upon I. So then this answer gets multiplied by I, which is 0.04. Then I do 1 comes here, and basically 1.04 comes here, and that 1 minus goes there. So I'll have 1.04. The whole raised to minus n is equal to 1 minus the answer. So 0.813299. Yeah. Now I take log. So this will become minus n log of 1.04 into log of this. So n will become, so log of the answer, basically the natural log of the answer divided by log of 1.04. You get minus, and the minus gets cancelled. So 5.269. Yeah. Now the point is you calculated 5.269, but the installments are annual. Either they come at time 5 or they come at time 6. There is no payment coming at time 5.269. So you round it up. So we'll say n is equal to 6. I basically round up to the next payment. You round it up to the next payment. Cool, guys. Now, I hope everyone's understood this. Now I go calculate this reduced amount of 6. Now, guys, ideally, ये equation क्या assume करता है कि 2,800 comes throughout till time n. We found that if it came till 0.269, it will be sufficient. So can I say this 2,800 is not required at time 6? Yeah, basically a reduced amount is required. मेरे को 5.269 मिल रहा है, मतलब 5 पे लोन रिपे नहीं हो रहा है, पर 6 तक जाने की जरूरत नहीं है, वो 0.269 वैल्यू पे ही खत्म हो जाएगा. Yeah, so basically, but still I'll have to round it up because the payments are allowed only in annum. So I round it up to the next payment. Guys, important here is next. Even if the answer was 5.03, I would have rounded it up to 6. I hope I'm clear. Yeah, it's the next payment. And it is next payment. So if it had been quarterly, I would have rounded up to the next quarter. If it would have been 6 monthly, I would have rounded up to the next 6 months. Since this is annum, I'm rounding up to the next year. Okay. So now basically a reduced amount will be paid at 6. For us, we have to find that amount. So basically 13,069 was there. After that, there at time, so this was time 12, 13, so on. 2,800 will be paid for a period of 5 years. And after that, there will be a reduced amount at time 6. So let's say I give that reduced amount as Y. So again, I'll make my equation of value. 13,069 will be equal to 2,800 for a period of 5 years. So A5 plus Y V raised to 6. I'll solve and I'll get the value of Y, the reduced amount. Yeah, which is nothing but 764.11. Guys, remember this, very, very important. Again, the last part I have not done, which is total interest paid, which is again multiple installment. We will do it in the next video. I hope everyone here is comfortable with respect to finding this. Guys, do this sum. This is a very good sum. It will help you refresh your basics. We look at multiple installment cases in the next video. Till then, bye guys. Go to